Hey, this is Mrs. Reichelt, and we are just about finished with Chapter 4. So last thing we have to talk about are the homeostatic imbalances of the integumentary system. So you'll see here there's a couple of pictures that we're going to talk about and then a couple of other conditions as well. So let's go ahead and start out with athlete's foot. Okay, athlete's foot is a fungal infection. And it causes an itchy red peeling condition. Doesn't that sound super fun? Okay, then we move on to boils and carbuncles. Okay, this is also caused by some sort of infection, except for instead of fungal infection, it's a bacterial infection. Okay, so boils and carbuncles are inflammation of hair follicles and of sebaceous glands. And then let's move up to another infection. So we have a fungal infection, a bacterial infection, and let's go ahead and talk about a viral infection. So cold sores are caused by the virus, the herpes simplex virus, and basically they're going to form all of these sores around the mouth. So they're small fluid-filled blisters around the mouth. So maybe I'll just put blisters. Okay, then we move to, let's do impetigo next, I guess. So impetigo is caused by another infection, except not viral, not fungal. This is going to be a bacterial infection. And what impetigo does is it actually is going to form these water-filled lesions. So all of those little bumps that you see are fluid-filled or water-filled. Okay, then let's go ahead and move to contact dermatitis. This is actually going to occur when you have some exposure to chemicals. So, exposure to chemicals, and it's an allergic reaction. And it's going to cause redness and swelling and probably itching too. And then the last one we're going to go through is psoriasis. Psoriasis is when there's abnormal cell growth of the epidermis. So there's an overproduction of epithelial cells. The cause is unknown, but it can be triggered by stress, trauma, or infection. So those are a couple of the homeostatic imbalances that have to do with infections and allergies and that sort of thing. Let's talk about burns next. So here are some great reasons of why you need to wear your sunscreen. Okay, so burns result in tissue damage and cell death. Caused by heat. Doesn't have to be heat, can be electrical. So electricity can cause burns, or UV radiation. Also chemicals can burn your skin. And some dangers are going to be, so the dangers associated with burning are obviously the actual burn that you receive is going to be a danger in itself, but some other associated dangers are going to be things like dehydration, electrolyte imbalance, and perhaps circulatory shock. Okay, so here's how doctors or nurses or anybody can really detect the severity of a burn. Okay, so the first thing we look at is the rule of 9. Okay, so when we are looking at the rule of 9, basically we use the rule of 9 when we're trying to determine how bad an individual is burned. So what they look at is the body is divided into 11 sections. So 11 areas the body is divided into. Okay? Each area represents about 9% of the total body surface. So each area represents approximately 9%. So that's the first thing. 11 areas, 9%. Basically, if so they're going to look at this, and then if you have over 10% of your total body has a third-degree burn, then that's a critical burn. If you have 20%, 25% of second-degree burns, you're at a critical burn. So basically, the rule of 9 is just a way to determine the severity of an individual's burn. Okay, so let's look at a couple different types of burn. I'm sure that you are most familiar with this one on the top, these first-degree burns. Usually first-degree burns result from a sunburn. So most of the cases, first-degree burns are going to be a sunburn. Only the epidermis is damaged. And then the skin is going to be red and sometimes swollen. Okay, a second-degree burn is pictured right here, and you see some blistering that's appearing. A second-degree burn, you're going to damage the epidermis and the upper dermis. So the upper dermis is which layer? What's it called? Hopefully you're saying the papillary layer. So we have our second-degree burns, and then this is going to be characterized when the skin blisters. And then our third-degree burns, doesn't this look terrible? Our third-degree burns are going to be considered critical. This is going to destroy the entire skin layer. So the whole skin layer, so we're talking about the epidermis and the dermis here. Skin can turn gray, white, or black. And skin grafting must be done as well. So that's where they take skin from another body part, and then they're going to try to grow it onto the damaged area. And our last little bit, where we'll talk about cancer. So cancer is an abnormal mass of cells. So cancers, or these can be classified in two different ways. There can be benign tumors and then malignant. All right, skin cancer is the most common type of cancer. So let's talk about 3 different types here. So we have the basal cell carcinoma, and it's going to look just like this. This is usually due to the sun exposure. So I'm just going to write sun right here. Okay, in addition, this is the most common type. So it's the most common type, and whoa, sorry about that, guys. I'm not even writing on this. Oh, I don't know. Hang on. I'm erasing things. I don't know what I'm doing here. Okay, let's try that again. So we have sun exposure. I'm not going to write that again. let's see, it's the most common, and then it's going to arise from stratum basal. And then we have squamous cell carcinoma. Okay, so that's going to look just like this right here. This will metastasize into the lymph nodes if it's not removed quickly. Early removal allows for a good chance of recovery, and this is believed to be induced by the sun, and it arises from the stratum spinosum. Then we have the malignant melanoma, so that's going to look like this. Okay, this is going to be the most deadly form of cancer. It's a cancer of the melanocytes. Do you remember what those were? Melanocytes are going to be those cells that are responsible for pigment. Okay, and they metastasize very quickly into the lymph nodes and blood vessels. So I'm just going to say spread to lymph nodes and vessels. All right, and our last little bit is our A, B, C, and perhaps E rule. So this is our way that we can detect abnormal looking cells. So if you're looking at moles, you're going to look at A, or asymmetry. Whoops, just one. Let me just start over here. My spelling is quite atrocious. Okay, so asymmetry. So this is where you want two sides that are pigmented, but they don't match. Then B is the border irregularity. So we're going to look at the border. Okay, so this would be if the border of a mole is not smooth. C stands for color. Okay, so if this would be an indicator, would be if you have different pigments in an area. D is going to be diameter. So if you have a mole that's larger than 6 millimeters in diameter, and then last, now they're looking, it's really just the ABCD rule, but now they're looking at E for elevation. So that wraps up your chapter 4. Now it's time to start studying.